Hi, what I want you to see in this video are a few things that we'll use in class on Friday. Friday will be Day of Silence, so Ms. Rogel and I will not be speaking in order to honor the Day of Silence, and so I just want to give you a couple things that we're going to be looking at then in class that you'll be working on with your small group. So as you've seen for days now that we're thinking about products of this number and sums of this number. So as you saw today with Ms. Rogel, I'm thinking about ways I can multiply to 12 and add to 7, which I know are 3 and 4. I also know that they're both positive because I have this lets me know that both the signs are the same, and this one lets me know that they're both positive numbers. So this one here, I still have the same product in this next example of 12, but this time my sum is 8. So I'm thinking about what multiplies to 12 but adds to 8. So I have x plus 2 times x plus 6. This is one that's a little bit more interesting or different. This instead, what I want you to think about is what could you do that would multiply to 9 and add to 6? So the only factors I know for 9 are 1 and 9 and 3 and 3. This one is the one that will give us also this sum of 6. So I get x plus 3 times x plus 3. We've seen this a couple times in class along the way. What this is right here is that you could also write this way. And we talk about this when we verbalize this. We say this is x plus 3 quantity squared. The reason why I'm using the word quantity is because it's letting me know that it's the entire sum of x plus 3 and then that's squared. This is called, for you, let me just give you vocabulary here. This is what's called a perfect square trinomial. Okay, so let's look at this. Trinomial we know because it has 3 terms. 1, 2, 3. Perfect square is because this number here is a perfect square. This 9 is a perfect square. So we're thinking about here on my square, if I went back to my area model, that I'd have x plus 3 and x plus 3. This is a square. So I can see that I'm getting this word square to appear in the verbal model, and I'm also getting it back here in my product that I'm looking for. So again, this is a perfect square trinomial. Cool. Okay, so let me just go ahead to the next one. So taking a look at this one. This is also a perfect square trinomial because I have a perfect square here, and I'm getting, if I think about 49, it's 7 and 7. It could also be 1 and 49, but that's not going to give me a sum of negative 14. So I have here x and x. I have 7 and 7 because they're going to multiply to 49 and still add to negative 14. And I know these are both minus signs here. So instead this time I would have, if I wrote this in exponential form, I'd have x minus 7 quantity squared. And if you check it, you could FOIL it out and you would get x squared minus 7x minus 7x plus 49. Right, if I do first and then outsides and then insides and then less. And then if you add that up, you end up getting back to the trinomial you started with. So again, this is a perfect square trinomial. It's a special kind of trinomial for us. This is yet another kind of trinomial. This is a binomial this time, not a trinomial because I only have 2 terms. This here, if you take a look at this, another way to think about this is to say x squared plus 0x minus 9. Because I do not have just an x in here, so I know my coefficient on my x term is 0. So I'm thinking now about ways that I could multiply to 9. So I have 1 and 9, 3 and 3. And then it's negative 9, so I have to think about the sign combinations there. But I want to add up to 0. I want something to cancel it out. So the way that I can do that is I can have it be x and x. I know, again, this is negative, so one is going to be positive, one's going to be negative to multiply to that. And when I plug in the 3 and the 3 here, the cool thing that happens is that I end up getting, I get my x squareds, but I get a 3x and I get a negative 3x. Those are going to cancel each other out. and then you have your negative 3 times, I'm sorry, your 3 times negative 3 to get you to negative 9. So this is very different than the last one. The last two were perfect square trinomials. We had the multiplication, then gave us a sum that we could use. This now is saying our sum is 0. So it's a little bit different. This is very similar. Again, I have a 0x in here. That may be really helpful for some of you to think about. How do I multiply to negative 49 but add to 0? So you know it's 1 and 49 and 7 and 7. So again, the way that I can get those x's to drop out, I have an x and an x. This is a negative, so I know one's positive, one's negative. If I have a negative 49 here, that means I could have a negative 7 and a positive 7. This is what's called difference of two squares. Difference we can see right in the binomial. We have difference, we have that subtraction part right here. Then the two squares. So here is your perfect, here's your perfect square is 49. So what's the difference of the two squares? And we can think about an area model if you want to also on that, if that helps. But we'll be using this all in class on Friday the 19th. Okay, I'm sorry I missed you today, but I will see you all very soon, and I hope you're all well. I'm thinking of you. Okay, bye.